Okay, we're going to take a look at our experimental probability worksheet if you need a little extra help. The first thing I'm going to do, let's just read through the problem. It says Nora tossed a number cube with faces numbered 1 through 6, a total of 100 times, and recorded the results in the table below. Okay, I'm just going to make sure I underline 100 times. That's really important we remember that. So let's just remember that our table here, this tells me that I rolled the number 1 24 times. I rolled the number 2 15 times, rolled the 3 18 times, so on and so forth. So the directions say use Nora's data to answer the questions. Our first question, which number did the cube land on least often, most often? So my suggestion for you today while we're working through these problems, once I read through the problem, hit pause on your computer, try the problem on your own, and hit play. And then you can check and see if you got the right answer. I'm going to work through all of these, and when I do, I'll try to say, remember to hit pause right now. But if I don't say it after we read the question, just hit pause on your own, okay? So let's see, least often, I'm going to look in the times toss and try to find the smallest number in here. And the smallest one I see is 8, and 8 goes with the 4. So I know that what I rolled least often was 4. Then what I rolled most often, let's see, for the biggest, I'm going to look for the biggest number here. I see I got the biggest number was 24, so the most often. What is the experimental probability of tossing a 1? Pause this and try it on your own. Hit play when you're done. I think it's 24, because I rolled a 1 24 times out of a total of 100 rolls. Remember, we really need to simplify this. We can't just leave it as 24 over 100. So I know that these are both divisible by 4. You could pick 2, and you could divide them both by 2. I'm just going to make a bigger jump, and I'm going to divide them both by 4. "24 divided by 4 is 6. 100 divided by 4 is 25. I'm going to check and see if I can simplify this anymore. I know 25 is 5 times 5, and 5 doesn't go into 6. So that lets me know I'm done. Question 3. What is the experimental probability of tossing a 2? So again, hit pause and hit play again when you're done. 15 out of 100. And I know that these are both divisible by 5. So I'm going to show you, if this way kind of confuses you, I'm going to show you a different way to simplify fractions over here. I'm going to rewrite 15 as 5 times 3. I'm going to rewrite 100. Since they're both divisible by 5, I want to write 100 as 5 times something. I want to have a 5 over 5, okay? Since they're both divisible by 5, I want to write them both as 5 times something. So I would write this as 5 times 20. 5 times 20 is 100. Well, we know that anything over itself always equals 1. So 5 over 5 is like a big 1. And what's 1 times 3 over 20? Well, that's just 3 over 20. We're done. We can't simplify this one anymore. So look here, what's the experimental probability of tossing a 3? Hit pause, try it on your own. 3 is 18, we got a 3 18 times, out of a total of 100 rolls. I know that these are both even numbers, so they're both divisible by 2. So when I simplify, I'm going to simplify like I did in this one over here. I'm going to write this. They're both divisible by 2, so I want to write them both as 2 times something. Well, 2 times 9 is 18. And down here, if I write this 100 as 2 times something, 2 times 50. 2 over 2 is 1. So I'm left with 9 over 50. Just going to check here. I know 9 is 3 times 3. And I know that 3 does not go into 50. So I'm done. That's my simplified version. Next, what is the experimental probability of tossing a 4? So it looks like we got a 4 8 times out of 100. So I'm going to write that 8 over 100. Let's simplify. These are both divisible by 2. So I'll write 8 as 2 times 4. I'll write 100 as 2 times 50. 2 over 2 is 1. That leaves me with 4 over 50. While I'm looking at this right now, I realize I still have 2 even numbers. So I'm going to divide them both by 2 again, or rewrite them as 2 times something. So 4 I could write as 2 times 2. 50 I can write as 2 times 25. 2 over 2 is 1, so I'm left with 2 over 25. And 2 is even, but 25 is not, so I can't simplify that anymore. Question 6. What is the experimental probability of tossing a 5? Well, let's look. 5 is 20, so it's going to be 20 over 100. I could do this 2 ways when I simplify. I know that they are both divisible by 10 because they end in zeros. But I also know that 20 evenly goes into 100. So I'm going to rewrite these both as 20 times something. So I'm going to write this one as 20 times 1. And I'm going to write 100 as 20 times 5. 20 over 20 is 1. That leaves me with 1/5. If you would have divided them both or wrote them both as 10 times something, you could have done that. And that would have given you, if you'd written these as 10 times something, I'll just erase that and do it again, actually, simplifying with 10. If you understand how to simplify fractions, feel free to fast forward. But I'm just going to rewrite this as 10 times 2 and 10 times 10. I know they're divisible by 10. Again, they end in zeros. 10 over 10 is 1, so that leaves me with 2/10. Okay, now I know they're both even, so I can write them both as 2 times something. So I'll write that one as 2 times 1, and I'll write this one as 2 times 5. 2 over 2 is 1, so I'm still left with 1/5. Either way, you'll get the same answer. Okay, let's take a look at the last 4 problems here. What is the experimental probability of tossing a 6? So that one will be 15 out of 100. These are all out of 100 because we rolled 100 times. These are both divisible by 5. So I'll write that one as 5 times 3. I'll write this one as 5 times 20. 5 over 5 is 1. Leaves me with 3/20. What's the experimental probability of tossing a number less than 4? Okay, this doesn't say less than or equal to 4. It just says less than 4. So my numbers that are less than 4 are 3, 2, and 1. So these are the ones I'm going to look at. Okay, so to find the experimental probability, I'm going to add these up. So I'm going to add 24 plus 15 plus 18. I'll just do that over here off to the side. Maybe you could do this on your own. Okay, when I added all those up, I got 57. So I'll give that a total of 57 out of 100. And I'm going to just kind of think through this. I know that I think 57 is a prime number. I'm thinking this off the top of my head. It's so high up sometimes we forget. But I know 100 is even. That's not. 57 is not divisible by 5. I'm going to add these up, and that gives me 5 plus 7 is 12. So that lets me know this is actually not prime. That 3 goes into 57 because when I add it up, when I add 57 up, I get 12. And remember, if you have a multiple of 3, it's divisible by 3. So I'm just going to test and just see really quickly how many times does 3 go into 57. I don't know that off the top of my head, so I'll do 3 divided by 57. As I'm thinking about it, I think it's 19. So let's see, 3 times 10, or 3 times 10 is 30, which leaves me with 27. 3 times 9 is 27, so that gave me 19. So I know that's 3 times 19, and 3 and 19, neither one of those goes into 100. So that's my simplified version. That one was kind of tricky to simplify. All right, number 9. What's the experimental probability of tossing a number that is greater than or equal to 4? Okay, well, if all my numbers less than 4 added to 57, I think that means if I add all those up, they should add to 43 because I rolled 100 times. So it'll give me 43 over 100, which is going to be my simplified version. This isn't even, it's not divisible by 10, it's not divisible by 5. I'm going to add up my digits, I get 7, it's not divisible by 3. So those are the big ones. All right, number 10, last one. What's the experimental probability of tossing a number that is a factor of 15? Okay, well, let's list out our factors of 15. We've got 1 times 15. It's not even, so 2 doesn't go into it, so we know 3 does. 3 times 5. 4 doesn't go into it, so we're done. I'm going to erase what I circled earlier. So let's look, what are our factors of 15 that are on the number cube? We've got 1, 3, and 5. So 1, 3, and 5. So let's just add those up like we did over there when we were doing number 8. So I'm going to add up 24 plus 18 plus 20. That's 12. So I give a total of 62 rolls out of 100. 62 out of 100 times. I rolled a number that was a factor of 15. These are both divisible by 2. They're even. So I'll rewrite this one as 2 times 31 and 2 times 50. Remember that 2 over 2 is 1, so that leaves me with 31 over 50.